Students, in the previous session, we have dealt the balancing of several masses rotating same planes. In this session, let us discuss about the balancing of many masses rotating different planes. Here for this, we adopted a procedure that is when the many masses rotating in different planes, they may be transferred to a plane called a reference plane. So all the planes rotating is transferred to the reference plane. So which is the reference plane passes through the axis of rotation and perpendicular to the axis. Here, the idea behind the transferring all the planes having the rotating mass to the reference plane is with every mass rotating in a plane causes a cylindrical force. So by transferring the plane to a reference plane such that the force in the reference plane transferring causes a cylindrical force which is equal in magnitude to the cylindrical force of the revolving mass. So by transferring the plane having the rotating mass to the reference plane is also create a cylindrical force which is equal in magnitude to the cylindrical force exerted by the revolving mass in the rotating in the separate planes. Also, when the rotating mass rotating planes create also couple. So by transferring the planes to the reference plane also gives a couple which is equal in magnitude to the product of force and distance multiplied by the distance between the plane of rotation and the reference plane. So we create a equivalent system by transferring the different planes to the reference plane. So all are equalized. That is the cylindrical force and the couple. So we make use of the reference plane from which all the planes of rotation are made distance. So in this system, in order to have a complete balance, the two conditions must be satisfied. So the net forces acting in the reference plane must be equal to 0. And similarly, the couple about the reference plane must be also equal 0. So the two conditions must be satisfied to have the complete balancing of the rotating mass. So let us consider there are 4 masses rotating in the different planes. 1, 2, 3, 4 rotating in the different planes. Now for the system to have the balance, the 2 masses are attached in the planes L and M. So the diagram shows all the position of all the planes of masses. So here we keep the balancing mass in plane M, L and M. So the distances are given from each planes. Here our procedure is out of these planes, one plane must be chosen as a reference plane. So let us assume the plane L is regarded as a reference plane. Here the distance between the planes are referred from the reference plane. So the distance of all the planes is taken from the reference plane L. Normally we adopt the distance is positive or negative. So the negative distance can be regarded when a plane is from the left side of the reference plane. When a plane is right side to the reference plane, the distance between the planes is regarded as a positive. So we adopt this system. Now let us consider the 4 masses rotating in different planes. That is M1, M2, M3, M4. So which have the radius of rotation R1, R2, R3, R4. Now in the planes L and M, we keep the balancing mass. Now initially we don't know the position of the L and M and also the magnitude of the balancing mass MM and ML. For that, we have to draw the vector diagram. Before that, we have to tabulate all the values. Here, the first column indicates the plane. So we write in the same order. We have drawn in the plane diagram. One, plane 1, then plane L, plane 2, 3, and M plane, and fourth plane. Here, the mass is M1 and reference plane ML and M2, M3, MM, M4. Then each radius of rotation R1, R2, R3. The planes LM have the radius of rotation RL, RM. Then the centrifugal force. So mass into radius. So the product is given here. Then the plane distance taken from the reference plane L. So the first plane is to the left of the reference plane. So it is regarded as the negative value. So minus L1, then 0. And second plane is from L to distance from the L. So all the distances are noted. Then the last column, couple. So force into distance. So the products are written here. Now from the centering column and the couple column, there may be unknown 1 or 2. Now we have to draw first the force polygon or couple polygon having the minimum unknown. So if the couple polygon has the minimum unknown, we have to draw the couple polygon and side we try for the force polygon. Now we draw the first couple polygon. Now the couple, the except plane 1, all are positive. So the vector diagram should be in opposite direction compared to the other vectors L, 2, 3, M4. All other couple values are positive, but except the couple value for plane 1. So it should be in the opposite direction. Here the O dash A dash represent the couple for the plane 1. So O dash A dash in the opposite direction. So all the vectors are drawn parallel to the plane angular position of the planes A dash B dash for A dash B dash is for M2 R2 L2 plane 2. Similarly, plane 3, plane 4. Here the up to D dash we can complete. So now we have to close the polygon by joining O dash C dash. So the O dash C dash represent the couple of mass revolving in the plane M. So now we can measure the vector A dash, O dash, D dash, so that we can calculate the mass of the rotating in the plane M, also in the angular position of the M. Here we can measure the D dash, O dash. From that, the mass having rotating in the plane M can be found. Similarly, we can draw the force polygon. So by using the values M1 R1, ML RL, so all the values are represented in the force polygon. So OA. So the vectors are drawn parallel to the angular position of the planes having the masses. Here the closing side is OE. So the OE represent the angular position of the plane L. Also we can know the mass rotating in the plane L, that is ML. So we can calculate by using measuring the vector, then we can easily calculate the ML. So from that, the force polygon and the couple polygon, we can get both the magnitude of the mass balancing masses and also the angular position of the planes having the balancing mass. So let us understand this concept by using a problem. A shaft having 4 masses A, B, C, D of magnitude 200 kg, 300 kg, 400 kg, 200 kg respectively, and revolving at radii 80 mm, 70 mm, 60 mm, 80 mm in planes measured from A 300 mm, 400 mm, 700 mm. Angles between the crank measures anti-clockwise for A to B 45 degree, B to C 70 degree, C to D 100 degree. The balancing mass are to be placed in planes X and Y. The distance between the planes A and X is 100 mm. Between X and Y is 400 mm. Between Y and D is 200 mm. If the balancing mass revolve at radius of 100 mm, find their magnitude and angular position. So in this problem, there are four masses rotating in different planes and different radius of rotation. That is RE equal to 80 mm, RB equal to 70 mm, like that. And each of the mass MB, MA, MB, MC, MD are given. And then the angle between the successive planes are also given. A to B is 45 and B to C is 75 degree. Then from the problem, the X and Y planes are denoted. So it is idea to having the or fix the balancing mass in the planes X and Y. The radius of rotation also given 100 mm. So now our objective is to find the um, mass of the balancing mass, that is mx and my, because we keep the balancing mass in plane x and y and also the angular position. So similarly, these are the data given. Now we draw the position of planes A, B, C, D. Here the from the A it is given, B is distance between the A and B is 300 mm. And from distance between the planes A and C is 400 mm. And also distance between the A and X is 100 mm. And distance between the Y and D is 200 mm. So similarly, all the planes are noted. Here the plane X is assumed as a reference plane. Sir, we can draw the angular position of the masses. Now let us assume the mass A is drawn horizontally. So the B and the plane is about 45 degree to the A. It is given. From B to C, it is 70 degree. From C to D, 120 degree. So A, B, C, D. So the angular position of the four masses are easily drawn. Now we have to find out the position of the plane X and Y. So we have to tabulate all the values. So the plane A, X, B, C, Y, their mass is given except mx and my. Then the radius is given. Now the centrifugal force is mass into radius. Similarly, the distance between the distance from the distance of the planes from the reference plane X. So the plane A is to the left of the reference plane. So it is regarded as minus 100 mm, that is minus 0.1 meter. Similarly, all the values are noted. Then couple minus 1.6, 4.2. Here we can easily note in the centrifugal force values, there are two unknown values, but here in the couple values, there is only one unknown value. So now let us start with the couple polygon. Here the couple polygon, as the first plane couple value is negative, so we have to draw inwards O dash A dash in the opposite direction with the value of minus 1.6. So all the vectors A and B, it is drawn parallel to the plane B, that is plan B. So similarly, C, D. Here the D dash and O dash can be joined. So the vector D dash O dash represent the couple value of mass rotating in the plane Y, that is 0.04 my. So the O dash D dash represent 0.04 y. Now we can measure the vector, then it gives the value 7.3 kg meter squared. From that, we can easily calculate the my value, mass of the mass rotating in the plane Y, that is 182.5 kg. Similarly, we can draw the force polygon O to A to B, B to C, C to D, D to E. Then the closing polygon side is O to E. So the O to E represent the magnitude of the mass rotating in the plane mx, and also the OE gives the direction of the mass rotating in the plane x. So the OE vector we can measure this 35 kg meter. So from that we can easily calculate the value of mx 355 kg. Now we can easily measure now we can incorporate these two angular position that is the plane X and the mass My. So from the vector and the polygon diagram, couple polygon, we can draw the angular position. Now it can be calculated the angular value. So by the measurement, the position of the plane X is 15 degree in clockwise direction from the mass Ma. Okay, so that is a problem. So we can easily solve the problem by the graphical method for the case of balancing of rotating different masses rotating in the different planes. So thank you.